Hi everyone. Now we are moving to the chapter number 6. Okay, energy sources. In that, primary and secondary cells is the topic. So here the primary and secondary cells. So what is mean by primary cell? What is mean by secondary cell? Let us see. A voltaic chemical cell is a combination of material which produce the direct current. That means DC current. Here call it as a direct current or DC current. That means the batteries are delivering which type of power supply, which size, which type of current, direct current of electrical energy from its internal chemical reaction. That means the cells are converts chemical energy into electrical energy. So this is a very important point in the examination. This type of questions may be there. These cells can be subdivided into two types, two classes. What are the two types? The first one is a primary cell, the second one is a secondary cell. The primary cell means it cannot be rechargeable. Once you are using that particular primary cell, the chemical reaction cannot be reversible. That means once you are using that primary cell, we can throw out use and throw process. There is no question of rechargeable. That type of cells here call it as a primary cell. CA. In this cell, chemical reaction are irreversible. Okay, during the generation of electrical energy, it consumes the material cannot be replenished by recharging, and such cells cannot be recharged back their original condition after discharge. Clear? Here, the first thing you need to remember, the cells are convert chemical energy into electrical energy, thus generating current is a direct current. In that, we have two types of cells. The first one is a primary cell, secondary cell. Primary cell means the cell, once you are using, it cannot be rechargeable or chemical reaction is irreversible. That's why it is a use after using the cell, we can't back to the original condition after discharge. Okay, it cannot be rechargeable. Coming to the secondary cell. In the secondary cell, it is easy to remember. Whenever those cells are rechargeable, those cells you are call it as secondary cells. That means you can use more and more times repeatedly. The chemical reaction is irreversible here. Reversible here, not irreversible, reversible. They're irreversible. So these cells names are storage cell. Secondary cell is also called as a storage cell or accumulator. Okay. So in this cell, chemical reaction are reversible. Okay, after discharge, such cells can be stored its original condition by passing the electrical current through it in the direction opposite to that of discharge current. While you are charging, the current while you are charging and discharging, both the current directions are opposite. Whenever the current directions are reversed, then charging and discharging are taking place. Okay, this is one type of secondary cell. Here, lead oxide anode is present. It is a positive terminal. Lead is a cathode. So sulfuric acid is a solution here, chemical solution. In that, we are providing plus and minus sign. If you want to get the current from this particular cell, as well as we can charging this particular cell with giving the current in opposite direction. So these current in directions, for example, this is a current direction, it is a discharging. For example, this is a current direction, it's charging. Okay, because it is a rechargeable battery in the secondary devices. Okay, secondary cells. Comparison. What are the comparison between the primary cells and secondary cells? The primary cells have a low cost, secondary cells is expensive. It is a small size, yes, it is a reasonably small. Short life, but comparatively long life because it is a reusable. Useless when discharged, yes, rechargeable. Lightweight, heavier. So these are the comparisons for primary and secondary cells. Then we are moving to the next topic is a cell and battery. In general terminology, as well as in your day-to-day life, you are call it as a battery. But battery is different, cell is different. See here, what is the difference? In case of group of cells, for example, I connected 3 cells here. This group of 3 cells is nothing but a battery. What does it mean by battery? Battery is nothing but a group of cells. So see here, a battery consists of a two or more cells connected in series. This is a series connection, or parallel, or both. Often maybe people call it as a flashlight cell, flashlight battery, which is technically incorrect. Right? Cell is nothing but a group of battery is nothing but a group of cells either connected in series or parallel or both series and parallel. Next one, voltage and current, say current of a cell. Okay, these are the two important parameters related to the battery. I mean cell. Battery is nothing but a group of cell, right? So in that cell, the first one, voltage. Voltage rating of a cell is given by open circuit voltage. Whenever the battery not connected to the any load, the open circuit terminals, just now is a plus and minus terminals, right? Here you are measuring this voltage between these two terminals. That voltage, that open circuit voltage is nothing but a that is voltage can be produced when not connected to the load. That is a rating of voltage rating of a particular cell. This voltage depends upon the type of material used, not on the physical size of the cell. Very important. Voltage is not depending upon the size of cell. Okay, coming to the current, capacity. The capacity of cell is nothing but a amount of current can be supplied to external load. Clear? Voltage rating is depending upon the open circuit voltage delivered to the load. The open circuit voltage across the open circuit terminals whenever not connected to the load. But capacity is nothing but a amount of current delivered to the load. It depends upon the condition, quality of electrolyte and physical size of electrodes. So very important designation between voltage and current of a cell. Voltage of a cell not depending upon the size of the battery, but current capacity of a cell depending upon the size of battery and electrolytes, and everything as being the same. Larger the cell, deliver the more current, longer period of time than smaller one. Okay, that is about voltage and current rating of a cell. Coming to the cell life. So here cell life, that means how much time it delivers the power, that means how much of capacity to store the energy, how much long, that is related to the cell. We will look at in the points. It is given by that period of time during which cell can be stored, yes, on a cell without losing more than approximately 10% of its original capacity. That means whenever keep on without connected to any load, we are stored batteries in the some place, some other place. 10% of charging, 10% recharging taking place, not more than that approximately. Okay, that will happen. But that type of discharging is nothing but trickle charging. So trickle charging means somewhat charging is losing by particular cell. So how to avoid that particular 10% loss here? The loss of capacity occur even cell is not used, primarily due to partial drying up past electrolyte and other chemical actions which can be changed in the material within the cell. So what we need to do, since they help to both these process, it is as well advisable to keep cool places in order to extend its life. That means, so it stores cell without losing a 10%, approximately 10% original capacity, right? So that's why it is a cool places. It is the batteries are stored in a cool places, placed in a cool places. Then we can extend their life. This is about the cell life. So this is about the class related to the primary and secondary cells. Thank you.